In this video, we are going to see the problem which is related to the finite automata with the epsilon move. Okay, so the first example we have taken, design the NFA with epsilon to accept the binary string having even number of zeros or a even number of ones. So first we will see what are the possible input. So what are the possible input? 0, 0, 1, 1. So even number of zeros and even number of 1, or 4 times 0, then 2 ones, or 2 0, 4 1, or 4 zeros, then 4 ones. And if the input is 0 0 1 means it is not accepted, or if it is 0 1 1 means also it is not accepted. So here we are going to draw the transition diagram with the epsilon move. So first we will draw the transition diagram for even number of zeros. Then we can draw even number of ones. Then we can combine that. So how will we draw the even number of zeros? So this is a state I have taken and I have given the name as a Q1. Then this is the next state, it is a Q2. So even number of zeros. Okay, so from Q1 to Q2, I'm passing the input value as a 0. So here it is only one 0 is there. The meaning is odd number of 0. But we require even number of 0. So if it is a Q2 as a final state, okay, if Q2 is a final state, okay, so we can't do that. So what we can do, we can make Q1 as a final state, and again from Q2 to Q1 we can use the transition and we can pass the input value 0. So first is 0, then second 0, so even number of zeros. And in between also we can have multiple number of ones. So here we can create the loop 1, and here also we can create the loop 1, and same for the 1 also. So we can consider this as a Q3, then next state as the Q4. Same what we are doing, we are making Q3 as a final state, and here the transition for the input symbol 1, and here also the transition for the input symbol 1, and we can have multiple number of zeros here, the 0, right? Then we have to combine this. How we are going to combine? By using another one state, Q0. Okay, Q0. So we can connect this. So here what we are doing, we are passing the symbol, empty symbol here. Okay, we are passing the empty symbol here. So this is a transition diagram for this example. So if we check with 0 0 1 1 1, so here it is 0. Okay, so here 0, then again 0. Okay, again 0, then here it will we need 4 ones. So here in a Q1 itself it will stay, so 4 times 1 1 1, so it will remain in the same state. So this is the one example. The next one, how to design the NFA with epsilon to accept the string over sigma is equal to a such that w is equal to a power n is even or divisible by the 3. Okay, so here a power n, so here n is a even or divisible by 3. Even or divisible by 3 means n can be, n value can be 2 4 2 4, then 6, so on. Otherwise it can be 3 6, then 9 12, and so on. So it should be a even number or divisible by 3. So here what we are going to do, we are going to use the branch. Okay, we are going to use the branch here. So first we will draw for the even number. So same what we have done here, the same thing we have to use for the even. So how we can use Q1. Okay, so I will draw here Q1. So we can make this as a final state itself, and another one state is Q2 here, then here A, and here A. So always it will be the even number. Then next, what is the next one? It should be divisible by A. Sorry, divisible by 3. So we are making this as a Q3 state. Then next state is a Q4. Okay, so we are passing the input symbol A. Then next one Q5, it is A. We are passing the symbol A. The next what we can do 3. Over here meaning is there should be a 3 A's, right? Because it is divisible. So what we can do from Q5 to Q3. So we can pass the value A. And what we are doing, we are making this as a final state. If we are making this as a final state means the transition from Q3 to Q4, it is 1A, then Q4 to Q5, second A, then Q5 to Q3 is another third A. Again, if there is a means again Q3 to Q4, Q4 to Q5 and Q5 to Q3. So now we can connect this. Q0 is the initial state here. Then we can connect with this epsilon. So this is a this is a transition diagram for this particular string, that is a power n. Here n is even or divisible by the